So probability of black pen could be the number of black pen over the total. So black pen we have 35. Total was 90. And you tap it into your calculator. And gotta have a really nasty number here. So you have to round up to 4 decimal. So it's going to be 0.3889. Same concept with the next one, but they kind of ask you something else. Ask you that what was the chance of having a black, I'm sorry, a blue and a red pen. Meaning that when you select them, it has to be blue. It has to be blue or red, right? So it has to be either one of them. Let me ask you: do we have anything that's any pen that have a blue and red pen at the same time when you write? Meaning that if I use that pen and I write something down, my ink gonna be appear as a blue and red at the same time. The answer should be no, because there's no pen like that. So if for that one, if you wish to find a blue or red pen, your probability of blue or red should be the number of blue pen that you have plus the number of red pen that you have. So 15 plus 15 is a blue. Red pen was 40. 15 plus 40. Oops, it should be right here. Kind of like color coding thing. Over 90. So if you type that into your calculator, 15 plus 40 over 90, it should give you 0.61 repeatedly. Four decimal, as usual. So next part asks you, what's the probability of not a blue pen? Not a blue pen, meaning it could be a red pen or it could be a black pen. And so there's two ways you can do this. Either you find out the you get the number of number of black pen plus the number of red pen over the total, or the other one. So for this particular example here, I'm going to do both so you can see the difference. So probability, not blue. So in this case here, the chance of not blue going to be, let's see, we got not blue, meaning it could be black or red. So 35 plus 40. Because 35 is a black pen, 40 is a red pen, over 90. Tap into your calculator. 35, 40, 90. That should give you 8.333 repeatedly. Right up to 4 decimal, obviously. So, alright. So the other way to find that. I'm gonna use this spot here. The other way to find out the same question C is this: probability of not blue. equal to 1 minus the probability of blue. Why, you may ask, where's the 1 pops up? Well, in statistics, everything adds up to 1, which is aka 100%. Therefore, if you wish to find something that's not a blue, all you have to do is just take 100% minus the chance that you have a blue. So in here, it's going to be 1 minus probability of blue with basically 15 over 90. Color coding. 15 over 90. And you work it out. Type it into your calculator. Which should give you exactly the same thing of 0.8333. So compare these two, it's basically the same thing. However, I would strongly suggest you to do this right here. Why, you may ask? Well, because in statistics, sometimes you have a missing value, missing information. Sometimes you just don't have it. So this is probably the best way to find out the probability of those, unless less likely you're gonna have a chance something error pops up. So now for the next part here, they ask you what's the probability of a black pen, not a red pen. Black, not red. Well, we do not have a pen that can write black and red at the same time. So therefore, the probability of black or not a red pen, it's just basically a probability of a black pen. Because we don't have a pen that has that. We don't. So, hold on. But wait a minute. We have a blue pen too. Oops. We have a blue pen too. So, the probability of black or not a red pen, meaning it could be blue, right? Yeah, black or not blue. So, in here, change it. I should have closed the parentheses too fast. Basically ask you black or blue. So same concept. It's going to be the number of black and blue over the total. So black pen in this case we have, which is 35. Number of blue that we have, which is 15. $35 plus 15 over 90. And right up to 4 decimal. That's going to be 0.5556. Really, I mean, in that perspective, meaning that you have like 55.56, 55 or 56 chance that if you're randomly selected, it's going to be either black or blue. Not bad, to be honest. Alright, so we're coming up to the next one. Experimental probability. Experimental probability is a little bit different than theoretical, because experimental is when you're actually going out and test that. So if you say that probability of having a boy or a girl is 50-50, but then if you go outside and you collect data, so you may find out that maybe a chance of having a girl it's more likely to have a boy. Vice versa. It's just experimental. So the formula is stay the same. It doesn't change. It's still probability of an event A is still going to be number of outcome A, number of outcome of event A over the total. It doesn't change at all. However, on experimental probability, sometimes it's going to be more, or maybe it's going to be less, depending on the situations. Really rare, exceptionally rare, that the theoretical and the experimental is exactly the same. Super rare. So let's suppose that a softball player hit 20 of her last 50 time at bat. What is the experimental probability that she will get a hit on the next bat? Okay, so hit is 20 over the total of 50 time at bat. Because they tell you here, hit 20, last 50 time at bat. So we wish to calculate the next time that was the experimental probability that you will get a hit, which is the probability of hit which is the total in this case is 50. The chance that she hit was 20. And you type that into your calculator, it's going to be, let's see, 2050.4. 0.4, which is 40%. If you play baseball, 40% is pretty much crappy, but it's better, hopefully. Alright, let's come on to the next one, the last one. I don't know about you, it's kind of exciting to step on the last one. So they ask you, give you a frequency table on the right, which is this table here. And they ask you how many times as the even number was actually rolled using the table. So let's count how many times you got an even number. This is even number, this is even, this is even. The frequency, aka the number of times that it happened. So in this case here, they ask you what's the probability that you roll an even number. So you have to count. So number of even numbers is going to be from the first time you rolled, that was a 2, was 3 times. And then you roll, that was a 4, 6 times. And you roll again, then that has to be a 6. Your number of times happened, it would be 6. You add those things up. It should give you 15. Then you have to find what is the total number of outcomes that you have. The big total at the end. All you have to do is just add them up. So total of the frequencies here. You got these numbers add up. Which is A plus 3 plus 9 plus 6 plus 4 plus 6. And you type it into your calculator. It should be 36. So the total number of row will be 36, and these are the event numbers. So if they ask you what's the probability that you roll an even number, this could be probability of even, which is 15 over the total you have, which is 8, which is 36. You type it into your calculator, 15 over 36 should give you 0.41, a bunch of 6. Route to 4 decimal again. For the next question, they ask you what is the experimental probability of rolling a number greater than 4. Greater than 4, meaning it could be 5 and 6. So greater than 4, it could be this number here, this number there. Same concept. We have to find out the outcome of those. Number that greater than 4. So number greater than 4, we know it's going to be either 5 or 6. And then the time that happened on 5 will be 4. Meaning if you roll a cube 36 times, the outcome 5 appears 4 times. And the outcome 6, it should appear 6 times. And you add them up, total will be 10. So to complete this, the probability of a number greater than 4 it will be 10 over 36. Then you have to type that into your trusty calculator. You can use your phone calculator. It'll give you the same thing. 10 out of 36 should be 0.2778. And again, I round this thing up to 4 decimal. Let's conclude the lesson about basic probability. If you have any question, feel free to let me know via Remind or Zoom or Google Classroom. Please remember you got work to do on Canvas on day 2 and day 5. Day 5 is a little bit much. I consider that. Alright.